All right, let's get started on today's PowerPoint, and this one is Investigating Basic Circuits. It's a pre-activity discussion. This is quite a long PowerPoint, so we need to get rolling here. All right, so this presentation is going to introduce you to basic circuits and their symbols. It's also going to introduce you to components and equipment that are fundamental to understanding circuits. Alright, it's going to define voltage, current, and resistance, and finally it's going to prepare you for activity 112, investigating basic circuits. Alright, so investigating basic circuits. You may have studied electricity and circuits in other classes, probably in POE, maybe in physics. But this is a guided activity that assumes that you have no prior knowledge of electricity. If you have studied circuits before, it can act as basically a refresher. So some questions that you need to kind of ask yourself as we go through this presentation. What are some of the basic components that make up simple circuits, and what do they do? What are the important characteristics of a circuit, and how do I measure different parts of a circuit? How do I work safely with circuits? How do I measure voltage? How does an arrangement of components affect the characteristic of the circuit? And finally, how can I use calculations to design circuits before I create one? A lot of questions there. Alright, so first let's look at equipment and tools. So in this activity, you will be introduced to the equipment, concept, and skills that are the foundations in studying electronics. So components, which includes discrete components. Remember, a discrete component is a digital component that has basically a 0 or 1. Simple electronic devices that affect electrons in a circuit. So that's what a component is. A breadboard. It's a reusable platform for prototyping. Basically, you create circuits without the need of soldering. And finally, a measurement tool that we'll use is the digital multimeter, or the DMM. And it's used to measure current, voltage, and resistance. And this equation right there is fundamental in what we do. Alright? Current equals voltage over resistance. So here's an example of several electronic components. Alright, you can look through there, you can see that they're rather small. There are ones that grow in size, but really they're very tiny. So here's a couple examples of basic breadboards. We do use that breadboard right there. You may have used something similar to that one in POE. But a breadboard is sometimes called a protoboard, and it's a reusable platform to build temporary electronic circuits. Some advanced breadboards, and we will use this as well. They basically have components in place for you already. They have some advanced features, but if you look, you'll see this one has a couple 7-segment displays. It has switches. It has push buttons, and it also has some LEDs down there. Alright, here is your basic, all your wiring components up there, and then this is really your basic breadboard in there. We'll look at how to use this later on. Okay, so how does a breadboard work? Well, electric component leads and the wire used to connect them are inserted into these holes. You can kind of see the holes there. And the holes are arranged in a grid pattern on the surface of a breadboard. If you look at the cutaway view here, you'll see that a series of internal metal strips serve as jumper wires that connect specific rows of holes. So a row of holes is all connected together. So it's kind of hard to see, but that row right there is connected together. You can see on the cutaway here, alright, that those are connected together. As they move left and right, they are not connected together. That's a little hard to understand right now, but you'll get it. So here's a better view of it. Okay? Up at the top here and at the bottom, you'll see how the red goes all the way across. Whatever is connected there is also connected there. What does that mean? Well, if I put 5 volts here, it's going to power up this whole strip here. So every hole has 5 volts in it. Okay. Now, when you get down into the working area of the breadboard, okay, now it works in columns, up and down. So whatever I plug in here, alright, so if I plug in 5 volts to there, down here is also 5 volts. But each individual column is separate from the column next to it. They're all their each individual stuff. Okay? Down here is separate from up here. It works the same way. Each individual columns are connected. Okay? But don't be confused. This column is not connected to this column. And this column is not connected to this column, and so on and so forth. Only the holes in the columns are connected. Again, we'll do an activity where you'll understand this a little bit better. So here are PCBs. These are printed circuit boards, and this is basically when you are not prototyping, when you're creating an actual circuit, for commercial use. This is what you would use. This right here, we're going to create a random number generator, and we're going to solder it, and you'll actually get a printed circuit board to keep. So why do you breadboard? Well, first off, it takes less time and money to create a circuit. Okay? Because of the cost, a printed circuit board should be reserved for the final working design. When everything is done and you know it works properly, then you can make a printed circuit board. Okay? We won't be making printed circuit boards here except one time, and that's just the random number generator early on in the course. Why also breadboard? Well, breadboard gives the designer ability to make quick changes to components, swap out capacitors or resistors. But a breadboard also allows the designer to easily modify the circuit to facilitate measurements of voltage, currents, or resistance. So it basically allows you to make changes. That's why we breadboard. So breadboard, let's get some guidelines and tips. And breadboarding is definitely a skill. We're going to build a circuit midway through the course that is going to require a ton of wires. And if you don't practice using good breadboarding skills, it's just going to make it extremely difficult. So you want to use few wires as possible and few jumper wires. And a jumper wire connects one hole to another. You need to keep wires as short as possible. Don't create a jumble of wires that's just basically a bird nest. Alright, a breadboard is a circuit so that it looks closely to the possible layout of the schematic circuit. Okay, what do I mean by that? Well, when you design your circuit on multisim, try to breadboard it exactly the way that it looks like on multisim. You need to place breadboards in the middle. You need to place IC chips in the middle of the breadboard. Okay, you'll see there's a little slot down the middle there. Alright, your IC chips should straddle that slot. Work from a schematic and check off the component and wires as they are implemented on the breadboard. So as you complete the breadboard, check off stuff on your schematic. And the leads on wires need to be cut to manageable lengths. Alright, if your lead is too long, then your wire can touch other things and then they short out. And always have someone check your circuit for errors. Alright, here's one of the tools that we'll use quite often. It's a digital multimeter, the abbreviation DMM, and it's used to measure voltage, current, and resistance. And this is exactly the type of multimeter we use. Alright, notice where the leads are placed. In the middle will always go the black lead, and we're going to use the red one on the far right. Okay, these symbols are important. That's direct current right here. Alternating current looks like this. Alright, current itself and resistance with that omega symbol. So in the activity coming up here, you're going to learn how to measure voltage. Alright. Also on your on a computer, you have a digital multimeter that's connected through your digital mini system. Okay, this is a digital mini system. It's something that we use quite often in here. You'll breadboard on this, and this white box here allows you to perform several different tasks, and one of them is a digital multimeter. Okay. Okay, so we're going to learn how to properly use a digital multimeter. It's critical to understand the proper way to measure stuff. Alright? When you're measuring those things right there, current, voltage, and resistance, there's a proper way to do it. Placing the leads, the red lead, the black lead, in the improper place will give you incorrect readings, and it could possibly damage the multimeter. So in this activity, you're going to learn how to accurately measure voltage. Okay, so circuit diagrams. In this activity, you will be introduced to the basic components of a circuit and how they're arranged. Each component has a symbol that can be used to create a circuit diagram. Alright, circuit diagrams and calculations help a circuit designer figure out the characteristics of the circuit before they begin prototyping or breadboarding the circuit. So here's an example of a very simple circuit. This circuit actually doesn't perform anything. You can see here there's a 9-volt battery. It's going to fire through a couple resistors, and it's going to come back. There's the ground right there. That's it. Nothing's going to happen in this circuit. But that's an example of a circuit diagram. Alright, hang with me here. Hang with me. We're almost finished. The circuit diagram symbols. These are important. We need to understand this. Analog. Analog is the opposite of digital. Okay? Analog power sources. We're going to use a voltage source. Okay? It can be anywhere from 5 volts to 9 volts, 12 volts, and there is the ground. Okay? Digital power sources. Voltage source, VCC, will always be 5 volts. Always. Your digital ground looks like that. Okay, discrete components. Here's an example of a resistor. That's resistor 1, that's how they'll label it, R1, R2, R3, and so on. And below the resistor, there'll always be a value. In this case, it's 330 ohms. This symbol stands for ohms, and it's a Greek symbol called omega. And here is an LED, or light emitting diode. Okay, that's a blue one. So this circuit, we imagine the flow of conventional current to be positive, moving from the battery all the way back to the negative terminal of the battery or the ground. So a circuit must perform a complete path in order for it to be complete. Alright, current. Current is the flow of electrical charge through an electronic circuit. The direction of a current is opposite to the direction of electron flow. Current is measured in amps. And there's a cat named Andre Ampere, French physicist. Awesome. Good looking hair. We're not going to worry too much, though, about the flow of electron. Physics worry about the flow of electron. We're not going to worry about it. So voltage is the force. That's a key word here. Force that causes current to flow in a circuit. It is measured in volts. Okay? So when you got a 5-volt battery, alright, that is the electrical force that causes the current to flow. And here's a guy named, I can't even say his first name, Volta. He was an Italian physicist. Now, resistance. Resistance is measured in the opposite direction to the current flow. It's called ohms. And again, there's the ohm symbol, and here's George Simon Ohm. He was a German physicist. All right. So ohms is the resistance. All right. Throughout this activity, keep considering what are some of the basic components that make up simple circuits and what do they do? What are the important characteristics of a circuit and how do I measure different parts? All right. Always think about working safely. How do you measure voltage? With a digital multimeter. How does the arrangements of components affect the characteristics of the circuit? And you'll see that. We're going to deal with series and parallel circuits. And finally, how can I use calculations to design the circuit before I start creating one? And you're going to use the formula that I showed you before. Alright, so now that you're familiar with some of the equipment and the concepts that are fundamental to studying electronics, you're ready to start exploring. Be sure to follow all safety guidelines. Answer all questions in as much detail as you can. You're not going to be graded on the accuracy of your answers for this introductory activity. Your answer will help shape class discussions at the conclusion of activity. Now, let's get exploring.